Hi, this is Dr. Subhatra. In today's session, I am going to explain about the flexural strength of concrete. It is a hardened concrete property. That property determines about the quality of concrete in the hardened state. So what are the three groups? We can classify the hardened concrete properties. It is strength, durability, and the dimensional stability. What do you mean by strength? Strength of the concrete means the maximum amount of load that it can handle. It is the most popular property, and we'll decide whether the concrete is good or bad based upon the strength of the concrete. It can be determined by means of compression, tension, and flexure. So what is compressive strength? The maximum compressive load that a concrete can able to take per unit area is called as a compressive strength that we have seen in detail. It can be carried out either in the 3rd day, 7th day or 28th day after casting the samples and curing it. These are the cube specimens, that is 150 by 150 by 150 mm size of cubes, which is used for finding the compressive strength of concrete. This is the formula we'll be using to find the compressive strength. That is the maximum applied load divided by the area of the cube mold. So this the table what I have shown here will give you the strength of concrete. How much percentage of strength will be attained in how many number of days. So in day 1, the concrete will have obtained 16% of strength, and at the 3rd day 40% strength. So after you test the concrete, after curing the concrete for about 3 days, when the test is around 40%, we'll conclude that the concrete is in a good state. Then at 7th day the concrete will attain 65% of strength, and at 14th day the concrete will attain 90% of the strength, and at 28 days the concrete will obtain 99% of its strength. So only after that 28 days we'll be removing our formwork. Then this is the specified compressive strength values at 7th day and 28 days I have given for different grades of concrete. Say for example, we'll take a M20 grade of concrete. It should have attained 20 Newton per mm square at 28th day and 13.5 Newton per mm square or MPa at 7th day. Well, what I have said here, at 7th day it should have attained 65% of the strength. So 65% of the strength for M20 grade is 13.5. If it obtains such strength value in the concerned day, that is the 7th day or 21 day or 28 day, we'll be able to judge whether the concrete has good compressive strength or not. What are the factors affecting the strength of concrete? First one is the type of cement. Based upon the composition, quality, age of material used in the manufacturing of cement, the strength of concrete will vary. Then coming to the nature of aggregates. The sand and coarse aggregate, that is the fine aggregate and coarse aggregate, are the two forms of aggregate we'll be using. Whether it produces a good bond between the cement and aggregate will decide the strength of concrete, and also the shape of aggregate, whether it is a smooth or rounded in shape. It will also determine, it will contribute to the strength of concrete. Coming to the water cement ratio, the compressive strength of concrete decreases when we increase the water cement ratio. And curing is very important. If you give a good curing for the concrete for the initial period, that is up to 28 days, the concrete will attain a very good strength, compressive strength. And also the weather condition. The same concrete, when you see, when it is placed in the different climatic conditions, will give the different strength values. So weather also contributes to the strength attainment. Then coming to the tensile strength. Plain concrete is very weak in tensile strength. That's why we are introducing steel bars to the concrete. Okay. Then we'll see flexural strength in detail. So flexural strength of the concrete is found using the beam. See, I have shown a picture of a beam. The size of the beam usually varies from 700, the length is 700, and B and D, breadth and depth values are 150 by 150 in millimeters. Okay, we have to prepare it using the tamping bar which weighs around 2 kg. By layer you will be filling it. This flexural testing machine, we have to place that beam after it has cured. The bed of the testing machine shall be provided with 2 steel rollers, this round and this round. There is 2 steel rollers which are 38 mm in diameter, on which the specimen is supported. These rollers are mounted at the center to center distance between 600 mm, because on either side 50 and 50 we leave. The total length is 700 mm. So in between 600 mm will be there, 50 on either side you will be leaving. Okay, load shall be applied through the 2 similar rollers which is mounted on the 1/3 point. We can see that in this diagram. So the 1/3, this is 1/3 distance and this is 1/3 distance, and here it is the 1/3 distance. Okay, load shall be divided equally between the 2 loading rollers, and all the rollers should be mounted in such a manner that load is applied only axially without subjecting any torsional stress to the restraints. Okay, so we can apply loading and in 2 different methods. The 3rd point loading or center point loading. In center point loading, we'll be applying load only at the center position. The entire load is applied at the center span. Here the half of the load is divided and it is applied at 1/3 of the span length. Here the span length is, total span length is 700 mm. The center to center between the 2 supports is 600. That 600, if you divide it by 3, it is 200 mm. Each distance will cover around 1/3 portion is around 200 mm. Okay, here the maximum stress is present over the center 1/3 portion of the beam. Here the maximum stress is present only at the center of the beam. How to calculate? After applying the load, the beam will bend and the cracks will develop. How to find out the flexural strength or the modulus of rupture, that is MR. Okay, we'll find out by means of these 2 formulas, PL by BD square. When A value is greater than 200 mm, here it is given in centimeters. When A is greater than 200 mm for a 150 mm specimen, what I have shown is a 150 mm specimen. Okay, we have to use the formula PL by BD square, where P is the maximum load applied in Newton, L is the length in mm of the specimen on which the specimen is supported, B and D are the measured width in mm, and D is the measured depth of the specimen in mm. Okay, when the A value, the same system will be doing for the next also. When A is less than 200 mm, here when A is greater than, A value is greater than 200 mm. Here when the A value is less than 200 mm, but it is greater than 170 mm. For the specimen size of 150 mm size specimen. Okay, we'll be using the formula 3PA by BD square. That A will give you the distance. Okay, distance that is 200, which lies between 200 to 170. Okay, what will happen when the distance is lesser than 170 mm? In that case, the test results we have to discard that. Below that value of A, we should not go for calculation. That will not be suitable for the flexural strength of the specimen. So, in this class, we have seen about how to conduct the flexural strength of the beam and how to do the calculations. Thank you.